Hi guys, I hope being at home finds you well. You're not too bored. In the event that you were too bored, I have made this lovely online lecture for you where we're going to talk about valence electrons. So if you remember before we left with this whole craziness, we were talking about what is inside an atom and we came up with protons, neutrons, and electrons. Protons and neutrons are found in the nucleus while electrons surround the nucleus. Protons are positive, electrons are negative, and neutrons have no charge. They're really just there to help glue the atom together or hold all those positive atoms, positive particles into the nucleus because normally they'd want to repel or get away from each other. We were also talking about the periodic table and how that was all organized. So the periodic table is organized by atomic number, which can be found, it's the whole number usually found, I think, on your periodic tables in the upper left part of it. And it represents the number of protons in that atom. It's specific to that atom, and if you change that number, you're going to change the atom itself, or the element itself, I should say. So if you go from element 1 to 2, you're talking about hydrogen versus helium, which are two very completely different elements. So we're going to start focusing on electrons because those are the really important parts in chemistry. Electrons are what keep atoms together atoms of different compounds together. They're what define chemical and physical behaviors and all that stuff that we've been talking about. So we're going to start by talking about valence electrons. In order to figure out valence electrons, the easiest thing you can do is actually look at the digit of the group number. So remember, the group numbers are on top, like 1, 2, and then you have the transition metals, which have their own thing. We're going to skip them for now. So start again after transition metals with borons group, so 3, 4, 5, 6, 7, and 8. If you're looking at the group number, everything in group number 1 has 1 valence electron. You can see that by the dot represented on this periodic table. Everything in group 2 has 2 valence electrons. Notice 2 dots on all of those elements there. And it goes on 3, 4, 5, 6, 7, and 8. When we represent electrons, we would usually draw them in a Lewis dot diagram or Lewis dot structure. We're going to learn about those coming up in the future. But valence electrons are the ones that are involved in bonding or combining with other elements. So we draw them as just a dot on the outside of our symbol. So for our example of calcium here, you'll know it's in group 2 because you look for Ca on your periodic table. And you would just draw 2 dots on the outside of calcium. What I want you to do is try and do oxygen on your own. You can look at that group number again and then just post a comment in our Google Classroom with how many electrons, valence electrons, oxygen has. Now, all the other electrons involved are going to be called core electrons. So calcium, again, for example, has an atomic number of 20. Which means that a normal calcium atom has 20 electrons and 20 protons. But we said only 2 of them are involved in bonding or in those valence electrons because it's in group 2. So the other 18 electrons are what we call core electrons. And those are held very closely to the nucleus, and they don't like to share their core electrons. They really only like to share the valence electrons. This brings us to atomic desire. So all atoms really want to have a full valence shell. A full valence shell will equal 8 electrons. And this is because your noble gases, which are group 18, have a full valence shell. And what you should remember, hopefully, from before break, is that noble gases do not react. Because they have a full shell, that means there's no space for any more electrons to come in, and they don't really want to give anything up. So it creates this very stable structure that doesn't really want to give any or take any more electrons. So all your other atoms or all your other elements want to have that full shell too and represent noble gas configuration, which we would call like an octet rule or noble gas configuration. In order to do that, atoms will either gain or lose electrons, so they either add electrons in or get rid of electrons until their valence shells are full. If we're talking about losing electrons, you're usually talking about elements with 1 to 3 valence electrons. These are all metals, and they lose electrons by getting rid of those valence electrons or those outer shell electrons so that their inner shells or core electrons represent those full structures. This also creates a positive ion. So remember, an ion is any element with a charge. But if it's positive, we call it a cation. And I like to remember cations because cats have paws, so they're positive. If I had my cat around here, I would totally, I actually do have my cat. Hold on. Come here, Daddy. Okay. This is my cute cat, Tibby. Notice he's got paws, and cats have paws, so the positive, so it's a cation. Now, hopefully that I made a fool of myself and my poor cat, Tibby. You will forever remember cations are positive because they have paws. I know, you hate me. Going. All right. So, in the example of calcium, we're going from calcium, notice it has no charge on it. We're going to lose 2 electrons. It becomes positive, and it becomes calcium with a positive 2 charge. Gaining electrons will happen with elements that have 5 to 7 electrons in their outer shell, and it's easiest to just fill that shell up. So again, remember we want a total of 8 electrons. So if you've got 5 to 7, it's super easy to gain. 3 to 1, whereas it'd be a lot harder to lose 5. These are all non-metals. So in our example here, losing electrons makes it negative, which we call an anion. I don't have a funny way for you to remember that. I'm so sorry. I don't really want to torture my cat anymore, but positive, cation, negative, anion. So you can see oxygen has valence electrons, and it wants to actually gain 2 more electrons to make that full octet or that full shell on the outside. So it starts with 6. And it wants to gain those last 2. And once it does, then it's super happy and stable. When you have elements with 4 valence electrons, so this is in group 14, they will either gain or lose, and that just really depends on the situation. So sometimes carbon will gain electrons, sometimes it'll lose electrons. It just depends on what it's bonding to, and we'll talk more about that later. So what I want you to think about is how many electrons are going to be gained or lost. So in order to figure that out, you have to determine the total number of electrons in each element. That's your first step. And once you do that, then you want to fill in the electron shells until you run out of electrons. Over here, I've kind of listed the shells for you. So shell number 1 is going to be closest to the nucleus, and it can only hold 2 electrons. Shell number 2 is a little bit farther away, it can hold 8 electrons. Shell 3 can hold 8 electrons, but then shell 4 holds 18 electrons. So the farther away from the nucleus you get, the more space you have, the more electrons you can put in there. So if we're going to look at an example with neon, it's element number 10, which means it has 10 protons, but it also has 10 electrons. So our first shell would contain 2 electrons, those are the core electrons, and then shell 2 would have 8 electrons. So because 2 plus 8 equals 10, we've used up all of our electrons. Shell 2 is our valence electrons because that's the outermost level. Shell 1 are our core electrons because those are inner and closest to the nucleus. That's all I have for you guys. I will post some practice ones for you, and we'll go over those tomorrow.